my talk is about how you can automate serverless infrastructure using a platform called AWS SAM. Um, so yeah, just go ahead and get into it. We're going to start off. I'm going to tell a little bit about myself for those of you who don't know me and haven't interacted with me in the past. It's kind of what I do, what gets me going. I'm also going to talk about serverless and infrastructure as code, which are two topics that are kind of key to this talk, and understanding a little bit about those two is going to help out a lot if you've never worked with them before. Then we're going to dive into kind of like the main, I guess, point of the talk, which is how you can use the AWS Serverless Application Model, or which is abbreviated as SAM, and to automate your infrastructure, serverless infrastructure in AWS, and kind of how to get started, some common commands, general structure of the files and whatnot. And then finally, I'm going to end with a demo on how I use SAM with a SaaS that I built for players of the video game Destiny 2, which is my favorite video game, called Guardian Forge. It's designed so this way players can create snapshots of all their equipment and create just a simple link that they can share out to anybody. So let's go ahead and dive in. So, in case you haven't figured out, my name is Brian Morrison. I am an infrastructure engineer turned developer. Before being a developer, I used to manage a data center and a network of over 20 warehouses across the US, consisting of Windows and Linux servers, VMware environment, and a bunch of Cisco gear kind of strewn about. Currently, I'm a senior full stack developer at a company called Tomato, and we're a telematics IoT company. I work primarily on the integrations team. I build integrations between us and other companies and other devices as we kind of onboard new companies. But I also build the UIs for various features that I might be working on at any given time. I currently hold 2 AWS certifications. I'm a certified solutions architect and developer, both at the associate level. Hoping to get my professional certification sometime next year. I'm also part of the AWS Community Builders program, so if you ever read my blog or watch my YouTube, a lot of it generally is AWS focused, because that's really kind of what I like to work with and what I like to write about. I'm also a husband and father to 3 young boys, 7, 5, and 2, so we're kind of right in the heat of the young kids stage of life with them. And then when I'm not hanging out with my family outside of work, you'll often find me either working out or playing Destiny 2, as I mentioned. Contact info is in the lower left-hand corner. All the links are on my link tree, which is listed there. I'll post links to these in the chat afterwards. And a couple of the main languages I work with are JavaScript. I build with Node, Vue, and more recently React. I also do a lot of work in C# for work. I've started exploring Go, so I'm doing a lot more with that. My favorite cloud vendor to work with is AWS, but our work uses Azure, so I'm often working with both of them at any given time. Okay, so what is serverless? It's a good point to start. So Wikipedia defines serverless as a cloud computing execution model in which the cloud provider allocates machine resources on demand, taking care of servers on behalf of their customers. And the reason I bolded and underlined servers is because regardless of what it's called, there are still servers underneath it all. But the main point is you don't ever have to actually manage them. Comparing that with something like a DigitalOcean droplet, where you're kind of given a Linux virtual machine and they kind of say, go have fun with it. You don't really ever have to see that with serverless services. The other nice thing about it is you really pay for what you use as opposed to what you don't. And it might sound a little weird at first, but if you've taken the same comparison with the DigitalOcean droplet, where I think their smallest price is about $5 a month for a droplet, you're paying a monthly rate for that. Serverless functions such as Lambda functions up in AWS often charge on a much smaller time scale. Lambda functions, for instance, they do charge on the millisecond basis, plus a little bit more complexity on top of that. But generally, it's a lot of cost savings in the future if you can set your infrastructure up the right way. This is a diagram kind of a typical basic AWS serverless application. I wanted to highlight this because serverless services, especially those inside of AWS, should kind of be thought of more of like building blocks of a bigger picture, as opposed to you use one service to kind of build everything. So if we follow this diagram, the top lane is kind of for the front end, whereas the bottom one is for the back end. If you're trying to access something like a React website, that's kind of, you have your artifacts that are built and published to create that static website. The files themselves are often stored inside S3, which is just general file storage, and then you'll often put a CloudFront instance in front of it. And CloudFront is a serverless CDN service up within AWS. Main reason you'd want to do that is because then you can add a custom domain to it. You get the benefits of like regional caching and whatnot, so it makes your application load a lot faster on the client. The bottom lane for the back end, often you'll have something like API gateway sitting in front of your Lambda functions. API gateway can be seen as kind of a front door into AWS or the different services that are available to it. The Lambda functions are going to be where your code is actually executed on a very, very small scale. So instead of a giant application, often Lambda functions are, a single function that has one single responsibility. And then DynamoDB is the most popular serverless database service up in AWS. So that's where you'd kind of like read and write your data from. So next we're going to get into what is IAC. IAC stands for Infrastructure as Code, and I like using definitions. So Microsoft defines this as the management of infrastructure in a descriptive model using the same versioning as DevOps team uses for source code. It's a big fancy way of saying, instead of having to go inside of a user interface and click around to build your various build the services that build your application, you instead would define something like a text file that's written in YAML, JSON, or Terraform has a proprietary format called HCL. And the reason why they say same versioning as DevOps is because this is often stored alongside the repository with the rest of your code. So the development team and the operations team is going to have access to that, and you get some of those benefits like version control that comes along, so you can see your infrastructure change over time. And often you'll use third-party tools to deploy these definitions up into whatever your designated cloud provider is. CloudFormation and SAM are two examples up in AWS. Azure has ARM templates, and then Terraform is kind of a generic platform which can reach into multiple clouds and do all kind of the same thing. Pros and cons of IAC. So as I mentioned earlier, infrastructure is version controlled, so devs have access to it, kind of all stored alongside the code and all that stuff. It is easier to redeploy as needed, so if you ever need to migrate a service from, say, one region in AWS to another, or even sometimes, depending if you're using Terraform, one cloud provider to another, makes it a little bit easier to do that. The definitions can be parameterized, which means you can swap out individual pieces of configuration to make the stack behave a little bit differently. And I'll show some of this when I get to the demo, because I technically have two environments that I run Guardian Forge with. I have a QA environment, which is in a completely isolated AWS account from my production environment. It allows me to do testing before I push everything out to production, just so this way there are no kind of surprises that might pop up. Cons, there's a learning curve. It's a new tool you have to understand, so it's going to take a little while to, get it kind of part of your whole tool belt, so to speak. And defining infrastructure as code is it's a little strange the first couple times you do it, but you get the benefits of it pretty quick. And the first run generally takes a little bit of time, unless you have a bunch of templates that you've saved off, just because you're often adding stuff, trying to deploy it, tweaking it, make sure it works. But once that first run is done, it becomes a lot easier after that. What is SAM? Amazon defines it as an open source framework you can use to build serverless applications on AWS. When you boil it down to it, it's really just a CLI. The CLI that you would install on your computer kind of manages connecting with AWS and pushing all of your code out there when you're ready to do so. It's an IAC solution from AWS. And the back end, it uses CloudFormation, so which is going to be important later when I get into the demo, because we're going to be using some CloudFormation configurations with the SAM configurations and kind of marry it all together to work the way it's supposed to. Benefits of SAM, general IAC benefits. That's a big one, which is why I really wanted to call that out. This one is very unique to SAM, and why I choose SAM over other tools. It does support local testing and debugging of your API code. So through using the CLI, you can start up a test instance of all your Lambda functions and just write against it, as opposed to having to deploy everything out into AWS before you can test and debug. As I said, it supports CloudFormation configuration, so if there's anything that is not directly supported through SAM, you could take your cloud config stuff or CloudFormation configs and put it right in the SAM template, and it'll treat it just the same way, which is really handy. And lastly on this side, built-in reference for text and transform functions. So this is really nice because you can have, say, a dozen or so different services, and then instead of having to know the unique identifier to reference those services between each other, you can use little snippets of code that can kind of act as pointers between the different resources that you define inside of your SAM template. How to get started with SAM. First and foremost, you have to have an AWS account. Pretty sure that's obvious, but you also need to create a dedicated IAM account. IAM stands for Identity and Access Management. It's more or less like a user account within an overall AWS account. And the key thing you want to note here is you want to make sure to enable programmatic access, because that's how the CLI talks to your AWS account. You'll need to install the SAM CLI, which I'll leave links for how to install and get started with this in the stream chat after I'm finished. But basically, it's just an executable you install, and it kind of takes care of all the heavy lifting. It's pretty straightforward. Optionally, if you want to take advantage of that local testing, you will need to have Docker set up and running. It'll prompt you beforehand when you do the installation. Highly recommend it, even though it is optional, because that's what gets you that testing ability. And then the last thing you'll need to do is take the API key and secret that you've gotten from the first step in here and put them inside of the user folder /.aws/credentials. And your file will often look something like this, where you'll have, it's just a key value store of your access key ID and your secret access key. A couple common commands just to want to cover real quick. SAM validate will analyze and validate your template just to make sure that you don't have any kind of typos or anything that SAM and CloudFormation is not going to understand. It's not a surefire way to make sure everything's going to work as you expect it to, but it's a handy step to make sure that all the basic checkboxes are checked. SAM build is going to compile your code, transform your SAM template into something CloudFormation can understand, and more or less just get you ready to deploy. SAM deploy does exactly what it sounds like. It will take all of your artifacts that you've built and it will deploy them out into AWS using CloudFormation. And last one I want to call out is SAM local start API, which is the command that you use to fire up that local API instance to test. Okay, here is just a very, very basic SAM template. At the end, what you're going to get if you deployed something like this up into AWS is an instance of API gateway and a Lambda function that would be defined inside your repository. You can see the code URI on line 20 is hello_world. That generally points to a folder that contains, in this case, your Node.js code. So just taking this kind of from top to bottom. Version and transform are kind of some metadata pieces that SAM needs to know on what version it's using, as well as what CloudFormation template it needs to convert it to. Description is a simple text description of your application. This is really handy to see it up inside of AWS. This will be added into CloudFormation, which we'll see. Globals are common parameters that are applied to all of your resources. In this case, our function timeout is going to be 180 seconds, and our API, we have a couple of cores values defined there. Resources is where you're going to spend 90% of your time working if you do get into SAM. This is where you would actually say, I want to take a Lambda function and I want to add it to my overall stack. So a lot of this is just understanding what a function properties are. If you can see on line 17 through 19 are kind of the header of a specific resource up in AWS. 17 would be the name of whatever your resource is, and that provides an easy way for you to reference it throughout your template. Line 18 is the type of resource you're trying to define, and line 19 through 31 define the different properties, and these are kind of unique to whatever service you're trying to deploy up in AWS. In this case, this is a serverless function, which also is a Lambda function. We have code URI and handler is how you would define the entry point to your code. You can see between line 23 and 25 we have some environment variables, and then 26 through 31 is where we're defining the events in which case this specific function should be executed. We're setting an API endpoint of /hello2 in order to execute this function and return something back to the caller. And then finally, something that's not actually displayed here, although we'll get into the demo, is those parameters that I was mentioning before, where you can swap in and out different configuration variables through your overall stack. Oh, and outputs. Totally forgot about outputs. These are kind of these are used if you need to reference different variables of your resources after they've been deployed. So for instance, if you look at the outputs down at the bottom of this template, line 36, it says bang get ATT. That's going to get the attribute of the hello world function, and ARN is a unique identifier up inside of AWS. So when this gets deployed inside of your CLI as well as up in the CloudFormation console, you'll see what that unique identifier for that specific Lambda function is, just as a way of referencing it. And last but not least, it's demo time.
Hey, Brian, what exactly is the serverless framework? Which sounds generic, but I think it's also a specific thing. Is that right?
So the serverless framework is a alternative to AWS SAM. It's built independently of SAM, and the benefits you get from there is you can actually use that with multiple cloud providers. So it does support both AWS, Azure, and I think GCP, but I don't 100% know for sure. Okay. It is another very good framework, very similar to this to work with. I've worked with both of them in the past. Okay, so this is the actual my project that I use for Guardian Forge. Okay, I want to hone in specifically this folder here, this stack folder. This is where I contain all of my serverless functions and the SAM template that I'm using to deploy all my infrastructure up into AWS. I have the SAM template template.yaml is open right now, and this is kind of where I'm gonna hop around and show off some of these functions and what the different how they all kind of work together. So you can see up top here we have the same all header and global information like we saw inside of the slides. Parameters, this is where those different pieces of configuration can be swapped in and out to do different things. As you can see, environment parameter is one of the first ones I have defined here. I have QA and prod, which those are used throughout the template to name things in certain ways. So this way I can quickly see what service, which service I'm accessing, whether it's QA or prod, even though they're in different environments. Site domain name, API, a lot of this stuff is just different pieces that are going to be passed in through the CLI once I go ahead and build this, and we'll see how these parameters are used throughout this guy. Okay, so scrolling down here, 55 is where my resources block starts, and I want to specifically call out line 56, this bucket here. So S3, as I mentioned before, is used for it stands for Simple Storage Service. It's just for storing objects, unstructured data up in AWS, kind of like a file system, but a little more advanced than that. So what this is doing is it's going to create a bucket. The bucket name, you can see I have this bang ref and then data bucket name param. This is actually going to reference the parameter that's passed in through the CLI, as opposed to me having to go in and hard code the name inside of here. And again, because I'm deploying this to multiple environments at any given time, I want to be able to swap that out. We have different pieces of configuration in here, like access control, how these files should be stored and who can access them. I've got versioning enabled, so I can go back and reference older versions of files so they don't get overwritten. And then CORS configuration rules, because these files inside of here are accessible to the public. Next thing I want to do is hop over to my create build function. This is one of the more advanced functions that I have inside of here, so I'm going to call out some of this. Lines 418 through 420 define where the code is being accessed. So you can see my code URI is build/create build. So if I navigate on my left-hand side here and go to builds, there's a folder here called create build with my code inside of here. The code itself doesn't really apply to what we're talking about, but I just wanted to demonstrate that the code is in there. And my handler is create-build. Now, if you're ever working in a JavaScript environment with Node.js, because you can build Lambda functions in Node, what you often would do is you'd use the file name dot whatever the name of your function is that's going to handle the event that comes in. However, in Go's case, it's going to compile a single binary that's executed, which is why my handler is the same name as my folder, because that's what it's going to default to. Policies, this is how I would set security policies for Lambda functions. Inside of AWS, every single resource, whether it's a single Lambda function, an API gateway instance, whatever, they all have their own security boundaries. So you need to explicitly tell AWS what this specific function needs access to. In this case, I want a CRUD policy applied to the data bucket. I want a CRUD policy for my DynamoDB table, and then I use an SQS queue. If anyone's familiar with queues and how message queues work, I do some dispatching of messages onto that queue to do some additional things, which I'll show you what that handler actually looks like a little farther down. Here's my API event I have defined here. If you issue a post HTTP to /builds, that's going to call this function and execute all the code that's inside of that Go file. And then here's all my environment variables that are passed in, and you can see I'm accessing things like my DynamoDB table, my data bucket. I also, Bungie's API has its own API key, so I have to pass that in there. I'm dispatching things off to Discord when it's done, so I get notified when new builds are created. I have my Algolia settings in there for search, so a bunch of stuff is all being done by this single function. Okay, and then back to the queuing, like I was mentioning, and I really kind of wanted to call this out because in a serverless environment, especially within AWS, if you've ever worked with something like Netlify functions, they're pretty much kind of thought of as an API. Like you're building an API within Netlify, and that's what it's designed to do. However, underneath the covers, AWS is built off of event-driven development. So in the case of an API, an event would be like an HTTP request coming in through API gateway. However, an event can be something different, and this actual Lambda function, instead of being triggered off of an HTTP request, it's actually being triggered off of a message being dropped onto that queue. So whenever a message is dropped onto my new builds queue to do some additional processing to the data that's coming in, this Lambda function will then fire and process the data however I want it to. In this case, I'm also doing some stuff with Discord. But the rest of the actual structure of the file is exactly the same. It's just the different type of event I wanted to call out. And lastly, kind of going again off of the whole event-driven development thing, this function here that I have defined actually will monitor my S3 bucket based on this events here. And what it'll do is whenever a file is added to that specific S3 bucket that has a prefix of builds and a suffix of JSON, this function is going to fire. It's going to take the data in and try and do something with it. And what I'm using this for is for creating this open graph images to make it nice and pretty when someone shares a link out onto Twitter. So I really kind of wanted to highlight the event-driven aspect of Lambda functions and I guess serverless as a whole in general. Any questions before I move on?
This is like I think the thing with AWS is just seeming so daunting, especially for people that don't use it on a regular basis. Did this come from like experience at work of using that like every day over the course of extended period of time?
No, this was by sheer willpower and determinism to get this thing working
Really?
because, yeah, I use AWS on my personal. I started working, and I'm going to go on a complete tangent here, but the reason I got into AWS is because back many years ago when I decided I wanted to start going towards the path of a developer from an infrastructure engineer, AWS was way farther ahead than both Azure and GCP, so it kind of made sense that that was going to be the one to do my studying
Mhm.
on. So I got my certifications for AWS. I got the Solutions Architect. I got that, and then I got hired at a company who was migrating to Azure. So
Mm.
that's how that all panned out. And this is
Okay.
just because, this is playing around with code. This is slowly tweaking things and growing this over time. And as with everything, once you kind of get a general understanding of any tool, it becomes easier and easier to iterate on your knowledge of that specific tool.
Yeah. Fair enough.
So, and another comment on AWS being a daunting topic. Um, what I usually tell people when they're interested in getting into AWS is you need to think like if you log in an AWS console, which I'll show. There's like actually I can do that right now. I'll skip ahead a little bit. Here we go. So this is the AWS console, and this is where we're going to see that deployment happen. If I click on services, all of these things are all different services that AWS offers. So when you say AWS, it sounds really like, oh my goodness, that's such a lot to take in. However, realistically, every single thing here is its own independent little sandbox. So when you want to start learning AWS, I wouldn't focus on start with AWS. Like let's start with understanding AWS Lambda, and then let's move on to understanding API Gateway. Take it step by step. That is what kind of got me, what finally made me successful in understanding how to work with AWS and put these things together. So the next thing I want to demonstrate is how I can run this app locally in order to access my API data. So I've got my front end already running, so I don't have to start that up. But I'm also going to show, I use a script runner, I guess you can call it, called make. So I have a make file where I can chain different commands together and compile them into a single command. If anyone's, I'm sure most people here have worked with Node, how you have like npm run dev, npm start, that kind of thing. Same concept. So in my case, I can run make build, and it's going to in turn run sam build. I can also use make run, and what it's going to do is it's going to first run build, and then run this command here, which is this sam local start API we saw in the slides. And then I'm passing in a JSON file that contains my environment variables for how I want to start things up inside of my local sandbox. And then I'm passing a port in. It defaults to port 3000. However, a lot of things default to port 3000, so I've decided just to change mine to 4000 to make my life easier. So we're going to run make run. And again, it's just going to run build and then start API sequentially. Then we'll expand this out. So you can see it's building all the individual functions that I've created inside of my folders here on the left-hand side. And then once it's finished building everything, it's going to give me that API URL that I can then access, and I'll demonstrate some of that too. So here it's saying it's mounted all of these different functions to the different URLs, as well as all of the actions that we have associated with those URLs. And if I go into, say, this guy here, this is my actual Guardian Forge website. I'm just going to refresh the page. here, and then you can see through the network requests on the right-hand side. Let's see, scroll down. For instance, builds I know is one of my calls, right? Or is it not a options one? Here we go. So you can see right here we're accessing localhost port 4000/me/bookmarks, and then if I look inside the console here, you can see it logs out that all the different API calls that were actually being pushed out, as well as some additional logging information that I've added in there for my own debugging purposes. Showing the dev-env.json file I currently have hidden because it has a bunch of secrets stored in it. I know, bad practice to store it with a repository, but it's private, so I'm not too worried about it. But this is something like what that JSON file would look like. So we have a parameters object and then a bunch of key value pairs that would then be injected as environment variables that I can access from the Go code. So for instance, if I go over to that same create builds function, I have right here, bucket name is equal to os.getEnv. This would be something like in Node.js, process.env.bucket_name. Same exact thing. And lastly, what I wanted to do is I want to demonstrate what deploying out something like this is. So I actually have a little bit of a unique environment. So I don't manually deploy things from my console. What I do is I use a DevOps pipeline through Azure DevOps. And what that will do is when I commit my code up in Azure DevOps, it triggers off a release pipeline, which in turn will call SAM build and SAM deploy with all the necessary switches that I need inside of there. So what I've done is I've staged kind of here something that I'm kind of working on. I've added a new block inside of my YAML file, which is just an update user info function, along with all the same different properties that I've kind of talked about before. So I'm going to go ahead and commit this. So I'm going to sync this up, and then we're going to go into Azure DevOps, and we'll just make sure that it actually fires away and starts deploying. The Azure DevOps portion of it is not necessarily important to this talk. The only reason why I'm doing it through Azure DevOps is because I have a lot of manual tweaks and stuff inside of Azure that I don't want to have to replicate down in my console. So go into QA and make sure this is okay. So this is in progress. So now if I go into CloudFormation and we'll refresh this, it's going to take a few moments before it actually reflects here, but we can actually see in real time this stuff starting to be deployed. Forgot to pray to the demo gods ahead of time.
Azure DevOps is basically like the big brother of GitHub Actions now, isn't that correct?
Yeah, so Azure DevOps was actually based off of Team Foundation services. Yeah, see, here's my build and deploy, so it's going to take a few minutes for it to go through this. Azure DevOps used to be called Team Foundation Services or Visual Studio Online. It's gone through a couple different iterations of names, but yes, ultimately it's like GitHub Actions with, in my opinion, a lot more power, a much nicer interface, and a whole lot more that you can work with. The benefits you get through something like GitHub Actions is I think it has, since it's more community driven, it has a whole lot more support for custom deployment things, I guess, because, people are building their own different triggers and things to publish stuff out using GitHub Actions. But same concept underneath it all.
You mentioned earlier Terraform.
Yes.
Can you re-explain again what the difference with Terraform versus what we're talking about here is?
So Terraform is another IAC tool. So it lets you write your infrastructure components as text. They have a proprietary markup language called HCL that is kind of a strange hybrid between YAML and JSON. It's really funky to work with initially. But the benefit that Terraform provides you is it's cloud agnostic, like the serverless framework. So you define your endpoint services that you want to, I can't remember what they're called right now, but you define your endpoint services you want to actually deploy to, and then those endpoint services have just like SAM associated configurations and types that you'd want to deploy to, and it all runs locally. So Terraform is a single executable that you would put on your computer, and it does all the heavy lifting for you there, whereas opposed to something like CloudFormation does it all in the cloud.
Okay, makes sense.
Did this fail?
What-
Oh no, it's
What's
still
interesting
packing
is
things up.
you can combine Terraform and serverless framework and SAM if you know how the infrastructure is going to be set up. I'm working on a project now that uses Terraform and serverless framework together to leverage the strengths of Terraform and the strengths of the serverless framework.
Yeah. I mean, these are all, at the end of the day, they're all CLI tools. So if you can make them all talk and work well together, then yeah, you can, sky's the limit kind of a thing. There we go. All right, so you can see our status is update in progress. If I come to events, you can actually see in real time what CloudFormation is doing. So right now we're creating a new function called that update user FN, or it's creating a role. This goes back to the whole security boundary concept that I described earlier. Since every single function has its own security boundary, the way that one AWS service can access another AWS service is done via roles, which is where you basically define your ACLs, access control list. And then every single function has a role associated with it. So that's what tells the function, hey, this is what you can access versus what you can't access. So it's updating my serverless REST API. And let's keep refreshing this a little bit, and we'll see it all go live. We're going to look at that function once it's done. Catch all permissions. There we go. So we've actually, the create process for that update user info function is actually complete. So now we'll leave this be because there's not a whole lot more to see here. I guess I can go here and I can pop through these. So resources will show you all of the different resources that you've defined within a single stack. These are called stacks up in CloudFormation. It's just a way of consolidating all your different services in AWS to a single logical component. Outputs, these are some of those outputs that I was defining. Again, not a whole lot of important stuff going on here unless you really need some hard information out of the CloudFormation deploy process. But I've just defined the API domain name and the CloudFront domain, neither of which I use anymore. So now if we go back in here, I'm going to go back into AWS. So I'll go back to that tab and we'll go to Lambda. And if I go to update user info, where am I? North Virginia. I got to switch to my region that I'm working off, which is US West 1. So we have, here is that new function that we created, update Guardian Forge -QA, update user info, and then just a random string after that just to make sure there are no conflicts. So thank you for joining my TED Talk.
So how would you compare that to like serverless functions in Netlify? Like what would be benefits of going this route versus going with serverless functions in Netlify as an example?
It depends on the complexity of your application. So if you're just looking to build a single API, I would 100% go with Netlify and Netlify functions and all that stuff. Fun fact for those of you who don't know, Netlify uses AWS Lambda functions underneath the hood. So if you know how to write a Netlify function, you know how to write a Lambda function. But the benefits that you get from doing something directly in AWS over, my camera keeps trying to autofocus, I'm sorry. The benefits you would get from using SAM or just basically AWS directly in general as opposed to doing Netlify is you have some of that extra capability of triggering your code and your Lambda functions based off of different events that occur in the system. For instance, with Netlify, you get an API, and they do a fantastic job of creating a really simple way to create a serverless API. But in my case, whenever a build file is added into my S3 bucket, I want to take that data and I want to transform it in some other way. That's all not going to necessarily be native to Netlify unless it is, and I don't know about it, not claiming that it isn't, but you just get the extra robustness of being able to manually wire different services together directly in AWS.
Yeah, that makes sense. And that's something that I haven't quite come across
Yeah,
yet
does
is
Netlify have queues?
event-based.
I don't think
No,
so.
not that I know of.
Yeah. And see, the cool thing about using SAM, as Brian's showing, is that you didn't have to go through the console and click through a bunch of stuff in order to create your resources and deploy things. You can do it all in code, from the CLI.
Yeah.
So the alternative is going to be navigating this gigantic console.
Yeah, and for instance, Guardian Forge, the entire stack for one of my environments consists of an API gateway instance, two S3 buckets, an SQS instance. I think I have 20 or 21 Lambda functions, and something else that I'm spacing on right now.
Wow.
But if I wanted to do this manually as opposed to writing it all in a single giant, and yeah, it's a giant text file. I think the last time I checked it was over 600 lines long. But it's that or go inside here and click, 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 click. It's like
Yeah.
it's a huge time saver once you understand it. But again, there is a learning curve, and that goes for regardless if you're using the serverless framework, SAM, Terraform. There's always going to be a little bit of a learning curve because it's a new tool.
Hey, Brian, I have a question.
Yes, sir.
What kind of traffic have you been able to get through the site? And like, are you ever worried about sort of the unlimited spend of the cloud as you're building?
Yes, I am worried about that, honestly. However, I traffic is not that high, not yet, at least. My highest day, I had about 1,000 unique users access the site at one time, and that was primarily because I had it shared out by another big Destiny Twitter account. I have not seen those numbers since. I think the most I've gotten independently is about 200 users in one day. So not tiny, but not definitely not huge. So far, I haven't even breached the free tier limits of AWS yet. So, however, my hard fallback, honestly, if it does start to grow, is Netlify and Fauna, is where things might end up. Just because I like the idea of having like, hey, you spend 20 bucks a month, and there's your Netlify site, or you spend $25 a month, and here's your Fauna instance. I know I'm boiling it down to be overly basic, but I think you get the idea.
Yeah, that's cool. You've been able to do all this under the free tier still.
hmm I was surprised. I thought I was going to have to migrate off a lot sooner. Um, so yeah, see what else. Okay, so about the serverless framework, I'm going to throw this out there. If you ever want to do this kind of stuff and you want to do it in Node, I recommend the serverless framework personally. I find it a little more friendly to work with, specifically because you can break up your file. You can break up that YAML file a little more. And last I checked, you can't do that with SAM. You're kind of stuck with one giant file. The reason I went with SAM for Go is because the serverless framework, although it claims it supports Go, the performance is absolutely horrendous. I mean, you're talking 30 plus seconds to test a single HTTP call through a Go function. And to put things in perspective, I have a Ryzen 9 with about 64 gigs of memory in my computer, so there's no reason it should take that long to execute a simple function just to return some text.
That's pretty wild. And that's only specifically with Go.
Yeah, I've used serverless before with Node, and I really liked working with that. It seemed to be easier and support more things because it is more community driven than something like SAM is. SAM is really good for what it does, but if you want to start doing some really crazy things, other frameworks might be worth looking at. Oh, there is a couple more things I want to talk about. These are some resources that I'm going to share inside the text channel when I'm done. So I will be posting the installation instructions, which is this getting started link here. Again, how to install the AWS SAM CLI, do all the stuff I talked about in my slide. But I also am going to share links for the different resources that are supported directly through SAM, which you can see are seven different resources here, as opposed to CloudFormation, which supports almost damn near everything in AWS. So SAM plus CloudFormation pretty much lets you do almost anything in AWS you want to, with the added benefit of you get to spin up your API locally and test it directly as opposed to having to deploy it first.
If you were to build this whole thing again, would you still do it the same way?
Yes, absolutely. Before I even decided to go this route, I tested a bunch of different options, and this is still where I ended up back at.
Cool.
So that's all I got.
Sweet.
Who's next?
Yeah, I'm good on questions. If anybody else
That was like
has any.
total James. That's all I got. Uncompressed. I heard
That's all,
Yeah,
folks.
that was a great talk, Brian. Thanks.
Thank you. I appreciate that.
This is the whole world that I have not gotten into and almost intentionally haven't gotten into. But I think you have a lot more background of managing that type of infrastructure.
Yeah.
But I think, like you said, it's just a learning process like anything else.
Yeah, I have a lot of experience piecing bits of infrastructure together through just my past, my experience in my past roles.
Yeah.
That's a lot of what that job is. So.
Sweet. Well, thanks for doing this. I appreciate it.
Yeah, of course.
Also, glad to
Yeah,
have you on board as an admin.
bounce into the Meetup stream in case people want to still ask questions for the next 10 minutes or so.
What do you mean?
I think he's just saying people can hang out. They can you can hang out in the text channel if
Oh,
you
yeah,
want
yeah,
to
yeah.
for a few minutes, just in case people have extra stuff. But I think for the most part, we're probably good.
Yeah, that's what I mean.
Yeah, Diamond. I see your content, Diamond. I've got this recorded. We're gonna put it up on the Learn, Build, Teach YouTube channel at some point. I'm gonna clip out anything irrelevant. So do we have anything else? You guys have anything? I guess we now have anything planned for the rest of the year, or is this kind of it?
Oh, I don't know, Paul.
We have one more talk in November. It's going to be Brett Fisher, and he's going to talk about Docker Compose in Golang.
Me gusta.
Yeah, you definitely got to turn in for that. It's let me see which day it is real quick. November 16th at 2 p.m. Eastern time zone.
November 16th, Thanksgiving week out in the U.S. Isn't it?
It's
Or is it
the week before.
Yeah, the week before. Yeah. All right. Very cool. I think I can stop sharing now, and I can probably stop recording.
All right.